This is a practical supportive session for industrial automation uh, module. And in this workshop, you are going to learn about the direct online starter. So as you can see here, this is the how it looks like a direct online starter. So this is your enclosure. We have the start button to start the motor and stop button to stop the motor. And so the motor is wired to 3 terminals of this overload relay, and the power is coming from the 3-phase AC mains through a main circuit breaker, which is not shown in this DOL, but normally it is mounted in a separate place. In a DOL, basically you have a contactor, 3-phase contactor to drive a 3-phase motor, and you might have some auxiliary contacts based on the requirement to drive additional indicator lamps. For the protection, there is a overload relay. This could be electronic or thermal overload relay. So basically the operator can start and stop the motor. And so this is a forward type DOL, which does not have the reverse direction control. Simply the motor can be driven into one direction based on the wiring that you doing to the motor. Either you can make it forward or reverse running by swapping 2 terminals, as you have already known from your lectures. If you take a look at the wiring diagram of a direct online starter, here you can see the power is coming from a 3-phase supply. So we have 3 phases, L1, L2, L3, and the output is from the DOLs taken from these 3 terminals and wired to a 3-phase induction motor. DOLs are typically used for motors less than 3 kilowatt power rating, where you can directly drive it from the AC mains, which does not have any significant effect on the power utility. And that's why they do not have any additional recommended features. Okay, right. When we come back to the initial device, which is the circuit breaker, where you can isolate or disconnect your DOL from the 3-phase supply, and it might have some current ratings you can select based on the motor rating, and if there's an overcurrent event also, this can be tripped, or by manually you can turn it on and off to supply the power to the DOL. After that, 3 phases come into the main contactor. Here you can see this is a 3-phase contactor which has 3 normally open contacts, and this is the coil of the contactor. So it has 2 terminals, A1 and A2. This is typically a 230 volt driven AC contact which has a coil rated to 230 volt. And additionally, this contactor has an auxiliary contact point, which is M1 and M2. The auxiliary contact points can be varied based on the requirement. You can mount many auxiliary contacts on top of the main contactor. You will see in a minute when we go back to our practical demonstration. Then after the main contactor, the power is coming to thermal overload relay. This is a thermal overload relay, but there are electronic overload relays, which is also used in for the protection of the motor. So if there's an event of overcurrent due to the short circuit or excessive loading of the motor, the current will be increased, and that is sensed by this overload relay, and immediately it is disconnected. The thermal overload relay also carries an auxiliary contact point, OL1 and OL2, which is used for control circuit wiring. So this is basically the power wiring of the DOL. Now, when we move back to the control wiring, so in order to wire the control circuit, you need to take supply from any three phases. Either you can select L1, L2, L3, and you need to connect the other end to the neutral. So which gives 230-volt supply for your DOL. Now, so it is starting with the thermal OL relay, which has this normally close contact. So that is wired to these 2 points. After that, you have the stop push button that is typically normally closed type push button. When you press it, this contact of the switch will be open. Then it comes to the 2 parallel normally open contacts. One is for start push button and one is for main contactor auxiliary point M1 and M2. After that, it is wired to the main coil of the contactor A1 and A2, and then the A2 is connected to the neutral. So the circuit is completed. So if you take a look at how this circuit works, normally someone has to press the start button. So once the start button is pressed, this path will be closed. So if there aren't any overload, and if someone not keep pressing the stop push button, the current can come through this path and go through A1 and A2 and energize this coil. Energizing this coil will result this normally open contacts to close. Thereby, the motor will be powered up. So, which here the main circuit breaker has to be closed before you turn on the start push button. So now the current is going through there. A1 and A2 energized, the motor is powered up. At the same time, the auxiliary contact M1 and M2 will be closed. So that is wired to your control circuit. Then this contact will be closed, so that that will latch your A1 and A2 coil. And therefore, if someone release the stop button, still the circuit can keep running due to this latch of the M1 and M2 contacts, and the circuit is completed. So the circuit can be the DOL can be stopped by pressing the stop push button. So if the stop push button is pressed, so this contact will be open. That will result turn off the A1 and A2 or the disconnection of power to this coil. So that will disconnect the power contactor terminals. Or else, if an event where the motor is overrun, overload, or in an event of short circuit, the thermal overload relay will be this normally closed contact will be open, thereby the circuit will be reset. So someone has to clear the fault and reset the thermal overload relay, then only you can start the DOL again back. So that is the basic theory behind the thermal overload relay. Now we will go back to the practical setup related to this workshop. As you can see here, this is the drawing for the direct online starter that we are using in our lab environment. So this is the wiring diagram. So we have 3 phases, L1, L2, and L3. This is the power, and we have the neutral, and PE stand for protective earth. So when we take a look at the power wiring diagram, you can see here, this is the main circuit breaker, which takes the power from 3-phase supply. and thereafter it moves to the main contactor K1, and then it goes to the thermal overload relay. So the thermal overload relay has two auxiliary contacts, L1 and L2, and 11 and 12, and 83 and 84. After that, it is wired to the three-phase induction motor. Now you can see here in this setup, so the power is coming to the three-phase induction motor, and the chassis of the motor is connected to the protective earth. So our power circuit is now completed. And the main contactor also has several auxiliary contact points. I will explain in a minute. For this practical setup, the control circuit is driven by 24-volt AC supply. In that case, we need to use a step-down transformer, so which is connected to one phase and the neutral, so which converts to 40-volt AC supply to 24-volt AC, because these contactors are designed to work with 24-volt rating, not 230-volt supply. In order to protect the control circuit from any short circuits or any kind of faults in the downstream, it is recommended to use a fuse. So that will protect your transformer from any kind of short circuits or overload. After that, it comes to the stop push button, and then the thermal overload relay. These are normally close contacts, and then comes to the start button, and after that it is connected to the main contactor coil A1 and A2. So in the event of the start button is pressed, the stop button and the overload are not triggered. The stop button is not pressed, and the main circuit breaker is turned on. Then this A1 and A2 coil will be energized. So once this coil is energized, the auxiliary contact 53 and 54 will also be closed. That will latch this circuit, and A1 and A2 will be powered until someone presses stop button or overload will trigger. By default, before powering up or turn on the motor, you can see here the power is coming to the this normally closed contact of the main contactor auxiliary point, and that is connected to the stop lamp. So this is a light indicator which gives you indication the circuit is off. So this auxiliary contact point 83 and 84 are connected to the another light indicator. This is the start, which is a green lamp. This is a stop, which is a red lamp. To indicate the fault, we are using a little yellow lamp that is also connected to the overload, because if there's an overload happens, this 83 and 84 will be closed. That will result the fault indicated to turn on, so the operator can understand there's a fault happen when this yellow lamp lit. So when the power is on, as you can see, the start button is pressed, the K1 is latched, and this main contact is closed, the motor is powered up. That will result this normally open contact to close, and the start lamp indicator will lit. So it is running, the motor is running, and the green lamp will be lit. In the event of overload, this 11 and 12 will be disconnected, so the whole circuit will be reset, and the main circuit breaker will be open. Sorry, the main contactor will be open at the same time until someone is resetting this. The fault light will be lit because this normally open contact is closed. So if the thermal overload reset and the circuit is come back, you can start the DOL again. And if the stop button is pressed, the power is reset, and this DOL comes back to its normally open position, because now it shows the stop indicator red lamp, which means like the DOL at its default settings. You have to note that if there's a thermal overload happens, definitely you have to reset the thermal overload by after clearing the fault, then only you are able to turn on the system. So this is all about the theoretical concept as well as the explanation of the wiring diagram related to the direct online starter. After this, you can demonstrate, or you can work on wiring this DOL at the lab and construct this circuit and test it using 24-volt supply. And you can do the power wiring as well as you can do the control wiring and understand the concept behind direct online starters.
So this is our direct online starter practical, and this is the wiring diagram that you should follow. We have this direct online starter wiring panel, and this is our 3-phase induction motor. So this is the main power in port, and where you get the 3-phase, and this is our main contactor, and it has an auxiliary point for additional contacts, and these are the 3 power contacts coming on, and this is used for wiring, control wiring, and then it goes to the thermal overload and then goes to the induction motor terminals. These 3 terminals should be wired to the induction motor, and this is our indicator panel as well as the start and stop button. Now this is the stop button, and this is the start button, and this is the stop indicator. Now the system is at default, it is stop condition, and this is our fault lamp. And this side we have this power into the auxiliary terminal. So this is a transformer, so it will convert the 240 volt to 24 volt in, and that is this. Here you can take 24 volt AC supply, which can be used for wiring this control wiring. So we will just do the demonstration with by pressing the start button. So let's go to the start. Right now the start button is pressed, and so the green indicator is lit and the main contact is turned on, so that will pass the power to from the main terminal from here to the induction motor. And now this is the healthy condition. Assume like there is a thermal overload trigger due to some overload condition. In that case we can demonstrate, since we don't have a overload condition triggering, we are just using this thermal overload manual trigger. We can try that part as well. So when the overload event happens, thermal overload trips, that will disconnect the power to the motor from the main contactor, and the yellow indicator is lit. And if you want to reset the whole system after clearing the thermal load, you have to reset the thermal overload back, and the system comes back to the default condition with the stop indicator. So you can refer the wiring diagram and complete this wiring for this practical, and complete this lab experiment.